Imagine a world where the assembly lines for cars and smartphones grind to a halt, not for lack of steel or glass, but because of a tiny silicon chip. In early 2021, automakers from Detroit to Tokyo were forced to slash production by millions of vehicles because they couldn't get enough semiconductors. These chips, the brains in everything from cars to phones, overwhelmingly come from one region, East Asia. In fact, over 75% of the world's semiconductor manufacturing capacity is now in East Asia. A single Taiwanese company, TSMC, alone makes 70% of the auto industry's key microcontroller chips. If that sounds like a lot of power concentrated in one corner of the globe, it is. So how did East Asia become the silicon center of the world? Why do Taiwan, South Korea, Japan, and increasingly China dominate the global semiconductor industry? This is the story of how East Asia won the chip race, and what it means for all of us. The dominance of East Asia in chips didn't happen overnight. It's the result of decades of strategic moves, historical twists, and technological leaps. Rewind to the 1970s. Back then, the United States was the king of semiconductors, and Japan was an up-and-coming challenger. In 1990, the US still produced 37% of the world's chips, a huge share. But over the next 30 years, the center of gravity shifted east. By 2020, America's share had plummeted to just 12%. Europe's chip industry also shrank dramatically in that time. Who filled the void? East Asian nations. By 2018, Taiwan had become the world's largest semiconductor producer, fabricating about 4 million silicon wafers per month, followed closely by South Korea, 3.6 million, and then Japan, 3.0 million. China, which had very little capacity in 2000, ramped up to 2.2 million wafers per month by 2018. Even Singapore, a tiny Southeast Asian city-state, was making slightly more chips than all of Europe by that year. It was a stunning changing of the guard. In the span of a few decades, manufacturing of the world's most critical technology had pivoted from the West to the East. But how and why did this happen? To understand, we need to look at a perfect storm of government strategy, industry clustering, talent building, and market forces. East Asian nations each forged their own path, from Japan's early rise and fall to Taiwan's foundry revolution, South Korea's memory chip empire, and China's full-court press to catch up. Let's break down the key factors that gave East Asia its edge. One big reason East Asia leads in semiconductors today can be summed up in two words: industrial policy. Governments in this region actively nurtured their semiconductor sectors from the very beginning, often in ways very different from the laissez-faire approach in the West. Japan was a pioneer in this regard. Back in the 1970s and 80s, Japan's Ministry of International Trade and Industry, MITI, identified semiconductors as a strategic industry and poured resources into it. The government orchestrated collaborative research programs like the famous VLSI project, Very Large-Scale Integration, in 1976, bringing together major electronics firms to leapfrog in chip technology. The result? By the late 1980s, Japanese firms like NEC, Toshiba, and Hitachi had captured over half of the global memory chip market, frightening US competitors. Japan's rise was so rapid that it sparked a chip war in trade. The US imposed sanctions and a 1986 US-Japan semiconductor agreement to counter Japan's dominance. South Korea took note of Japan's success and followed a state-led strategy as well. In the 1980s, under President Park Chung-hee and successors, South Korea identified semiconductors as key to its economic future. The government funneled cheap loans, subsidies, and protection from foreign competition to its rising conglomerates, the chaebols like Samsung, Hyundai, which became SK Hynix, and LG. With government backing, Samsung Electronics in particular made a bold bet on memory chips. Samsung licensed technology from abroad, hired foreign experts, and by the mid-1990s it achieved what seemed unthinkable, overtaking established players to become the world's leading memory chip maker. By 2019, Samsung held 43.5% of the global DRAM memory market, with compatriot SK Hynix grabbing another approximately 29%. Together, they controlled well over two-thirds of the world's memory chip supply, a stranglehold that had effectively pushed most other competitors out of the market. This was not mere luck. It was industrial policy in action. Taiwan had a different challenge. It lacked giant conglomerates at first, so the government built the industry from scratch. In the 1980s, Taiwan's government established ITRI, Industrial Technology Research Institute, and tasked it with developing semiconductor know-how domestically. One legendary move: Taiwan recruited a veteran Chinese-American engineer named Morris Chang, a former Texas Instruments executive, to come home to Taipei and spearhead its chip strategy. In 1987, with government funding and tech transferred from the West, Chang founded TSMC, Taiwan Semiconductor Manufacturing Company, a new kind of company dedicated purely to manufacturing chips for others. This foundry model was novel at the time. Most companies made chips they designed themselves. But it proved visionary. TSMC could take designs from anywhere, an Apple in California, for example, and mass-produce those chips with world-class quality. The government didn't just seed TSMC, it also backed the creation of UMC, another chip maker, and nurtured a whole ecosystem of suppliers. The payoff has been enormous. TSMC is now the undisputed world leader in chip fabrication. It alone commands over 60% of the global foundry market and is the only company currently mass-producing the most advanced chips. This success was anything but accidental. It was engineered by national policy. China, meanwhile, was late to the semiconductor party, but it's making up for lost time with sheer government muscle. The Chinese government views semiconductors as a strategic cornerstone for economic and national security. Over the past decade, Beijing has unleashed massive state investments, an estimated $150 billion in public funds so far, to boost its domestic chip industry. They've rolled out ambitious plans, like the National Integrated Circuit Industry Investment Fund, often just called the Big Fund, and made semiconductors a focal point of the Made in China 2025 initiative. China's approach is unprecedented in scope and scale, pouring money into new fabs, supporting state-owned chip companies, and even acquiring foreign chip firms, or sometimes stealing intellectual property, as Western officials allege. The goal? To achieve self-sufficiency and leapfrog into a leading position by this decade. As of 2023, China's government had already launched multiple phases of its Big Fund and catalyzed dozens of new chip fab projects across the country. The common thread: East Asian governments treat semiconductors as strategic and act accordingly, offering subsidies, setting up research institutes, protecting infant industries, and partnering closely with private sector firms. The impact of this can be quantified. According to the Semiconductor Industry Association, SIA, it is around 30% cheaper to operate a chip fab in Taiwan or South Korea than in the United States, and up to 50% cheaper in China, largely due to government incentives like grants, tax breaks, and subsidized infrastructure. In other words, a huge chunk of the cost advantage that drew manufacturing to Asia was politically created. As analysts Chad Bown and Dan Wang note, the heavy involvement of foreign governments was a major factor in Asia's manufacturing ascent. Crucially, industrial policy wasn't just about money. It was also about vision and focus. By coordinating industry efforts, Japan's consortiums, Taiwan's foundry model, and by cushioning the risks of this capital-intensive industry, East Asian governments allowed their companies to play the long game. Companies like Samsung and TSMC invested tens of billions in new plants and R&D, confident that their governments had their backs during downturns. In contrast, many Western firms, with less state support, pulled back investment in rough times, losing their edge. It's a classic story. When it comes to semiconductors, the tortoise, with a steady state hand, beats the hare. Yet, government support alone isn't the whole story. Geography and community played a big role too. That brings us to another secret of East Asia's success: the power of clustering. Semiconductors are famously complex to manufacture. It takes hundreds of steps, thousands of specialized tools, and a web of suppliers providing everything from ultra-pure chemicals to precision lenses. This complexity means that proximity matters. One of East Asia's biggest advantages is how it created dense local ecosystems for chip making. The clusters, where industry, academia, and suppliers all mingle. Think of it as East Asia's own network of Silicon Valleys, but focused on silicon itself. Take Taiwan's Hsinchu Science Park, for example. Established in 1980 in a then rural part of Taiwan, Hsinchu was modeled after California's Silicon Valley, but supercharged by government planning. Today, Hsinchu Science Park is sometimes dubbed the Silicon Valley of the East. It hosts TSMC's headquarters and multiple fabs, other chip makers like UMC, a swarm of chip design firms like smartphone chip designer MediaTek, and countless suppliers, all in one area. Stroll through Hsinchu, well, if you could get past security into the fabs, and you'll find that if TSMC needs a new batch of chemicals or a replacement part, the supplier is often just a short drive away. This physical concentration creates enormous efficiency. As one example, TSMC's own 8 giant fabs in Taiwan collectively process about 2.3 million wafers per month, a scale that benefits from being clustered. That capacity is heavily concentrated in a few sites, meaning talent and suppliers naturally congregate there as well. A similar story unfolded in South Korea. The South Korean semiconductor industry is clustered largely in Gyeonggi Province, around Seoul. Samsung's huge campuses in places like Hwaseong and Pyeongtaek are not only state-of-the-art fabs, they're the centers of gravity for an entire network of partners. Drive an hour from a Samsung fab and you might hit a key chemicals supplier, an equipment maintenance provider, or a university research center feeding new engineers into the pipeline. In fact, the South Korean government recently announced plans to build the world's largest semiconductor cluster by 2030, linking Samsung and SK Hynix facilities with dozens of material and equipment makers in a massive high-tech corridor. The reason? They know that clustering breeds innovation and resilience. When companies are near each other, knowledge spills over. Employees hop between firms, taking expertise with them. Suppliers coordinate closely with manufacturers, sometimes, literally, over lunch. Problems get solved faster, iteration cycles speed up. And consider Japan. In its heyday of the 1980s, Japan's chip prowess was aided by industrial clusters around regions like Tsukuba, known for science and R&D, and the dense network of electronics companies in Tokyo and Osaka. Japanese firms also benefited from clustering in another sense. Many were part of giant keiretsu conglomerates, business groups, that internally shared technology and manufacturing. Even as Japan's market share fell, it retained strength in specialized niches, like semiconductor materials and equipment, often centered around long-established locales in Japan. For instance, the world's best semiconductor materials companies, photoresist, silicon wafers, etc., are Japanese. and many are clustered around manufacturing hubs in Japan, feeding into the global supply chain. The cluster effect means East Asia's chipmakers operate in an environment that's hard to replicate elsewhere. If an American company builds a fab in, say, Arizona, as Intel and TSMC are now doing, it also has to build or import an entire support ecosystem. In Taiwan or Korea, that ecosystem is right there, fully formed. Why does this matter? Because it translates to speed and agility. When a new chip design is ready, a Taiwanese fab can often get it up and running faster, since the needed talent and materials are on site. And if there's a sudden surge in demand, say a new iPhone requiring millions more chips, an Asian cluster can more readily scale up production by drawing on nearby contractors and workers. This density also fosters a culture of collaboration. Companies form alliances, and employees network at local cafes and conferences. The whole region becomes a giant semiconductor brain trust. It's worth noting that the demand side clustered in Asia too, reinforcing this effect. As Western firms outsourced manufacturing of electronics, countries like China, Malaysia, and Thailand became assembly hubs for phones, PCs, and other gadgets. By 2020, 62% of global semiconductor end demand came from Asia, with China alone accounting for 34%. Think about that. Most of the chips made are ultimately used in Asia, whether in factories or consumer markets. This created a self-reinforcing loop. Chip fabs moved to Asia to be closer to the electronics assembly lines and customers, which then made Asia even more attractive for new fabs. Where the customers go, the suppliers follow. East Asia ended up with both the makers and the takers of chips, all in one broad neighborhood, feeding off each other's growth. One vivid example of cluster synergy is how quickly knowledge and talent circulate in these hubs. In Taiwan, TSMC has spun off a web of talent. Engineers who trained at TSMC have left to start their own design companies or join smaller fabs, propagating best practices throughout the island. In South Korea, Samsung's intense training of engineers, Samsung famously runs its own engineering university programs, means even suppliers and smaller firms benefit from a highly skilled labor pool in the area. And that brings us to another crucial ingredient: talent. East Asia's dominance isn't just about policies and clusters, it's about people. Semiconductors are at the cutting edge of science and engineering. You don't become a chip leader without a deep bench of bright, skilled people willing to tackle extremely difficult problems and work very hard at it. East Asian societies have invested heavily in education and cultivated a culture that supports the demands of high-tech manufacturing. Let's start with education. Countries like South Korea, Taiwan, Japan, and now China all have educational systems that emphasize mathematics, science, and engineering from an early age. By the numbers, students from these countries consistently rank at or near the top in global math and science tests. This creates a strong domestic pipeline of engineers and scientists. In South Korea, for instance, engineering is a top field of study, and not by coincidence. In the 1970s, as Korea geared up to industrialize, it founded institutes like KAIST, Korea Advanced Institute of Science and Technology, to train world-class engineers domestically. Likewise, Taiwan established top engineering schools, like those at National Tsinghua University and National Chiao Tung University, both conveniently located near Hsinchu Science Park, which became feeders for the chip industry. Japan historically had some of the world's best engineering education and corporate training programs. Companies like NEC and Toshiba would hire top graduates and put them through rigorous in-house technical apprenticeships. On top of domestic education, East Asian governments and firms also sent their brightest minds abroad during the early years. Taiwan and China especially used this strategy. Throughout the 1980s and 1990s, scores of Taiwanese and Chinese students went to US graduate schools to study electrical engineering, semiconductor physics, and related fields. Many of them gained expertise in American labs and companies, then returned home, sometimes lured by government incentives or patriotic ambition, to help build local industries. Morris Chang of TSMC is a prominent example, educated at MIT and Stanford, and having risen in Texas Instruments ranks, he was exactly the kind of experienced talent that Taiwan needed. Similarly, China's 1,000 Talents program in the 2000s aimed to entice Chinese engineers and scientists abroad to come back with their know-how, though not without controversy in the West. But education alone doesn't explain East Asia's dominance. There's also a work culture and labor advantage that these countries leveraged. Semiconductor manufacturing is hard work. Fabs run 24/7, and the jobs can be arduous. Imagine spending hours in a cleanroom suit, monitoring equipment through the night. In the US, by the 1990s, many skilled workers found they had easier or more lucrative career options. For example, jumping to software companies or internet startups, which often paid more and had a hipper image. East Asian workers, by contrast, tended to stay in manufacturing roles longer, partly due to different economic opportunities. As Morris Chang observed, when TSMC was starting out, Taiwan's GDP per capita in the 1980s was a fraction of America's, so a job in semiconductor manufacturing was one of the best gigs in town. Taiwanese, and similarly Japanese and Korean engineers, were more likely to build lifelong careers at companies like TSMC, Toshiba, or Samsung. This meant lower turnover and a steady accumulation of expertise on the production line. By contrast, American chip firms in the 80s and 90s struggled with higher turnover. Skilled workers might leave for better pay or a career change. The result: fabs in East Asia could maintain seasoned teams of technicians and engineers who refined their craft year after year. One anecdote drives this home. At Texas Instruments in the 1970s, where Morris Chang ran semiconductor operations, the company faced so much employee churn in its Dallas fabs that it was difficult to sustain a stable manufacturing culture. Years later, Chang noted that in Taiwan, TSMC didn't face that problem. People were eager to stick with the company because few alternatives matched it in pay or prestige. In essence, East Asia's rise coincided with a period when its own talent had strong incentives to stay local, while the West's talent often dispersed into other sectors. There's also something to be said about work ethic and corporate culture. This can be subjective, but leaders like Morris Chang have pointed out that Taiwanese and Korean firms operate with an almost obsessive focus and long-term mindset that can be a competitive advantage in manufacturing. Long hours, company loyalty, and continuous improvement are common themes. Western observers sometimes remark on the relentless pace inside a TSMC or Samsung fab. The expectation is to constantly push yields higher and defects lower. That kind of intensity can burn people out, but it has also driven technical breakthroughs. On top of that, consider how talent begets more talent. Success stories inspire the next generation. Today, young engineers in East Asia see national heroes in people like Lisa Su, the Taiwan-born CEO of AMD, or Jensen Huang, the Taiwan-born CEO of NVIDIA, making global waves in semiconductors, or they see the wealth and prestige that founders of major chip companies have earned. This creates a positive feedback loop. More bright students go into semiconductor engineering, more startups form in the space, and the talent pool deepens further. Meanwhile, in the West, for a long period, semiconductors were seen as a mature or even declining industry. Many top graduates in the 2000s preferred to join software, finance, or other fields. Only recently, with the hype around AI chips and the geopolitics of chips, has there been a renewed excitement in the US and Europe about careers in semiconductor manufacturing. In summary, East Asia built a formidable human foundation for this industry through education, international knowledge transfer, and creating an environment where skilled workers devoted their careers to mastering chip fabrication. The result is a reservoir of expertise that's hard to replicate. As of 2022, for instance, Taiwan alone had over 40,000 engineers working in the semiconductor sector, many with decades of hands-on experience. How do you catch up with that overnight? You don't. And that's one more reason East Asia stays ahead. So, why does East Asia dominate the global semiconductor industry? As we've seen, it boils down to a potent mix of forward-looking policies, tight-knit industry clusters, skilled and dedicated talent, and the momentum of market forces that created an almost self-perpetuating lead. East Asian nations treated chips as the oil of the 21st century, a resource worth investing in and protecting, and that foresight paid off spectacularly. They built the fabs, trained the people, and courted the business, while others shifted focus or assumed the status quo would last.